And we're online, so welcome to Wednesday. This is something slightly different. It's the Programming Club. I've dropped the C++. Why? Because I want it open to everyone. So we're going to start with something new today. What should it be? Let's start with mischief. Let's get up to some mischief. Here we go. So, welcome to Amberskies, the Programming Club. This is episode 1. Yeah, that's not bad, is it? Topics, I've got keyboard input and entity component systems. Keyboard input I normally avoid. You're going to see why. Entity component systems was something mentioned last week by one of our subscribers. So I thought that's worth a closer look at. Now, let's start with the keyboard input, should I? Why do I normally avoid keyboard input? The reason is because there's no right way of doing it. Let's just take a bigger look at this now. So, welcome to the stream, everybody. I hope you're going to enjoy this because, I know I am. Keyboard input, let's start there. Let's go darker colours, please. Thank you. So, what do we got? We've got a keyboard. There we go, that's about right. We've got a keyboard here. So this is where we're going to start. What I'm going to do first is... Let's see what my notes are going to tell me to do. Oh dear, I can't remember anything now. Right, yeah. What we're going to do is we're going to create something called an input backend. Yeah. And there's going to be an input front end as well. Alright. So I'm going to call this backend. Now what does this mean? It means there's going to be a back and a front, obviously. Why? And that's the biggest question in programming. Why do we split these up like this? It's an interesting idea that programming these days has come up with. And it's basically this is, how can you put it? How it does stuff. So this is the actual core algorithms, core. How can we put it? So this has to get input. Right, so the back end covers the operating system. So obviously it has to be close to that and accept events. We then have to map these into the front end. And the front end is where we have that's the action of the input. So accept events, input actions. So events from the input. These then have to be mapped over to the front end, which takes the final action. I'm explaining this badly. I know I am. Okay, so the back end needs to be able to receive receive events, and that's on the from the operating system, and they have to be fed in, usually from usually through, should I say, an event handler. The front end is what we're interested in as the programmer. The front end is what we do. We take all of that information, and if they hit a key that says, you know, object goes left, the object goes left. That's what we program in the front end, the effect. So the final action or effect. So what does that input effect type of thing? There's reasons why we have to split it. Because say we have, let's see, WASD. So keys. Let's give myself a bit more room on that. So input backend. So this is a bit that we're really interested in. So if I take WASD, as keys off the keyboard. Now W maybe go forwards. So that will go into system for movement. So that may map to there. All of these could, and D would map through the system movement to, let's see, W, D. So that would be forwards, and that could be backwards. Okay, but also W could be part of a key combination for something else. So put brackets around that, put brackets around that. So if you press W, it could go into another key combination. And that could drop out a completely different effect, like hover, or jump, or open a screen. It could do quite a lot of things. Alright? So one key could be used for multiple different things. Now, we've already done key bindings, and you saw that, I think it was last week or the week before, where we did some key bindings, and we showed how we could read in like an assignment of keys to do certain things. But I want to use an ECS system, so we have to have some kind of abstract method here. So we have to abstract our way through this from here. And this can cause complications. So, yeah, as you can see, the squiggly lines are now starting to go all over the place, and it's an absolute mess. How do you design a system that's an absolute mess? That's a very good question. So let's go back to the start. We need to design a system which we can abstract. This needs, let's go this way. Back end, so let's go this way. Okay. So we're going to need some kind of event handler. that's for certain. So this is going to be our little box of event handling. And it's not going to do anything except be there. Okay, so things can inherit from it. This is going to be how we handle events. This is going to describe that. So it's going to be a complete abstract class. Now, what does this mean to us? It means that we're going to have to somehow get keyboard messages to it or through it. So that's going to be part 2, which is we are going to take the operating system. So operating system, events, and we are going to pass those through the event handler, and hopefully we will be able to manage it by making something. We'll make a temp. We'll go with a temp to start off with to show how it's done, and modify from there. I think that's probably going to be the best way. I'll choose SDL here for the operating system events. We all know what SDL is, and SDL2 should say. Yeah, I think we can do that. Yeah, and I'm going to go on Linux and do this, I think. I'm going to use SDL2. It's just easy to program with over there. So, yeah, right, so that's the whole system really. Is operating system events filtered or passed through an event handler, and we are going to take from that some kind of temporary way of outputting this event handler and using it. Temp, because it's going to be modified later. Right. Operating system events, SDL2, event handler, temp. I think we can do that. That's not so heavy and big, is it? That should fit within 2 hours. So let's go with that, shall we? Okay, I've got a virtual machine here, so click start. Let's have one of these. I don't know if you know, but I'm not allowed to have Linux on here anymore. This is a Windows machine. Don't care what the boss says, I can get around anything. I'm running a Windows program, aren't I? Yes, Oracle Virtual Machine, or VirtualBox. And there's a little line at the bottom. Can we not have the little line at the bottom? There you go, it's gone. There we go. So, Wednesday the 25th of September 2019. Password, okay. Blades, yeah, that's me. Good. KDE, Plasma. Cool. I like this. Oh, here we are. Right, okay. So we've got you. We've got a connection. There we go. Looks like Linux to me. This is KDE Linux. I created this using Manjaro Architect, because I wanted certain things on it, and then I just followed the instructions for VirtualBox, and hey ho, there we go. It's blank. Let's have a look. This is when my screen used to go black. It's because I was looking at this screen. So let's see what we've got. As long as I'm going to be using C++, so I've got a file there to start us with. I forgot GDB because I didn't have it before. Yeah, we've got GDB, which is the C++ debug, although I haven't tried it out yet. STL, is that all in? STL2 image. I think am I supposed to have all of this stuff in as well? I think I am. I know I'm going to need the networker. Oh, well, oh, TTFCS. We've messed around with all of this stuff already, and it's not on here. But we'll see. We'll see what I need when I need it. I think I've got most things covered. Or I hope I have. Well, we'll just pick up what we need when we need it. Alright, let's have a look in here. Oh, I've got graphics 5, okay. That's the build. Okay. And what have I done with this? Alrighty, we've got development. I've set it all up for Git. And it's C++, that's fine. Don't need you anymore. Libraries. Async, Glue, and SDL2 I'm using here. That's what I've been given. Async. Nice. There we go. That's Async is used for loading 3D objects, like OBJ files and stuff like that. Glue is used for the OpenGL extension wrangler, which gives us all our OpenGL commands. I think we've met this before. Yeah, that's Glue. And SDL2 we've met before. Let's see what includes I've got here. I think we've got enough to start with. Yeah, okay. Yeah, we've got everything. Game controllers and all the rest of it. Windows and God knows what. Okay. That looks good. We've got some models. Monkey 3 OBJ. Okay, I think we're going to be using... Well, I think that's already in use. Shaders, basic, common, and null. Okay. GLSL files, I'm not bothered about that at the moment. Alright, what we got here? Vec3, Vec2, Vec4. Right. Right, okay. Very basic. Nothing in there. Right, okay, I'll look through all of that lot in my spare time. I've set up the Git on this. That's what I was doing this morning. Making sure everything was up to date. So, how much have I done with this? Absolutely nothing. I did have to sort out this main, though. In our main, I'm in a virtual machine, so I've got to be more careful. Now, I've got no OpenGL in a virtual machine, or so everybody tells me. So num instances isn't going to work at a lot. Let's see what happens if we've got it at 10. Alright, let's go to the build area, terminal, run build task. Does this work? Bum, 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 bum. Yep, that seems to work. And if I try and run it, I get monkey heads. Yes, I thought so. And yeah, I was expecting that. There's only 10 on screen, and already, yeah, we're on the edge of 60 FPS. Keyboard, nothing. Absolutely nothing. I think that's roughly about it. Right, yeah, so it's a basic OpenGL we've got running here. That's fine. Put that up to 100. Let's see what kind of FPS I get. I wrote the build task as well, by the way. I had to do that. Okay, close you. And let's just try that again. And yeah, FPS went down the drain, which is to be expected. There's no graphics card. Now, if this was on the Windows machine, which is the host of this lovely thing, we'd probably be able to get about 5,000 quite easily, I would think, before we started noticing FPS. I will go down to, I think, 1 for now. Save. I think I put it on Control B. Yes, I did. Thank you. And it's just up arrow, and let's see where it puts it. Oh, it's just going to put it in a random place, isn't it? And that FPS is locked. So I can now see that the FPS is locked. Okay. Matrix, blah, 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 blah. Yeah. Yeah, okay. So X across, I'll put to 0.0f, comma, and Y up, I'll put 0.0f, comma, and Z, we will put to minus, let's try -3. I don't know what scale I'm at here. So -3.0f. And that's just 2 of those. And why have I got, oh, I've got the 4th one, comma. So it says vector3f, and then it's got 4 attributes. What on earth? Will that work? Let's just try it. Yeah, that's what I was thinking. X, Y, and Z. So that's correct. What do we need for the translation? That's it. So I don't know what this rand thing is set around for. run scale, blah, 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 blah. Comma. Ah, right, yes, I've got too many of these now. That's right. That's it. Nope. Okay, come on. It's not giving me highlighting either. No, that is right. 2. So what's the error here? Expected an expression. Pardon? Oh, I see. Right, okay. I've altered it a little bit too much, it would seem. That comma shouldn't be there. That's what the problem is. There you go. That's why I love having this system. Right, so save. Build. Pardon? Warning, variable rant scale. Oh, right, these are warnings, aren't they? Yes, you're just not being used now. That's fine. It's telling me that these things here aren't being used. Yeah, right. So let's get rid of you. Alright, let's not put it in the correct place. So is it +5? +3. I want to know which way this is looking, first of all, before I start messing around with that. I want to know which way the camera is. Don't do that. Let's find out. That's better. Yes, it's going the positive way. So now we can see the monkey head in all its glory with its bricks on. Great. What a fantastic, glorious monkey head that is. And we are looking from behind because we didn't set it to look at us. Fantastic. Alrighty, where's these rotations? Instance transform, matrix transform, array matrix transform, blah blah blah, base array. Right, okay, yeah. Blah-de blah-de blah. Parameters face culling, call back, primitives, yeah, draw func less. We haven't got blend in. While app is running, counter, update. You might notice what this code is if anybody's been watching on the Saturdays. Blah de blah, update timer, blah de blah de blah. Alright, we'll get to that, I think, later. Yeah, there's our rotation. Alright, I'm not going to do anything. I'm not going to mess around with anything more in there. And there's our main. That looks very familiar. I wonder why. So, where do we start? That's the first thing. How many of these have we got open? Right, okay. So I just hit that and it disappears. Good. Alright, so I've got ourselves down to 1 monkey head. Thank God for that. Sorry, I just didn't want the test thingy going. Lovely. Why are these underlined? Because it's a class, and that's a class. Right, so I've got underlined classes now, have I? Okay, fantastic. This is a new one on me. Thank you, Visual Studio Code, for surprising me yet again with your highlighting thingies. Coffee's good. Right, let's do something serious now. Let's do the input backend. Right, so let's go into core, source core, rendering core, there it is. What can we do here? We've got our window timing, memory common, and application. Right, I remember what some of those are. So let's try this then. I will make in core a new file. I'm going to call it I for input, and then it's going to be application event handler, and that's going to, what style are we using here? HPPs, okay, dot HPP. That stands for header plus plus for C++. There we go, and so that we can see here. There we go. We can see it now. What shall we have? Alright, well, I'm writing this, aren't I? So I can put my thingy on it, can't I? So let's pop you in. Lovely. 25th of September 2019. That's today's date. Yeah, it's not the game club anymore. It's the programming club. So, programming. Now, I need to differentiate. And that's a hash pragma once. Lovely. So we've got a file. Got a file I can mess with. This uses a common header. So common H. Got one. Alright. Hash include. So I'll pop you in. That gives us everything that I'm going to need anyway. So that's fine. Why don't you like it? Hash include errors detected. Please update your include path. Right. Edit include path settings. This is IntelliSense configurations. No. Okay. Add to include path $workspace folder / source. No. It should already be there. Okay. I don't know why it isn't. So that will be $. I thought I'd fixed all of this. Workspace folder / source / asterisk. Save. It's worked. Okay, we can now include things. Good. Right, first problem solved. Let's have our class. There is very little name spacing in this. Thank God I left all of that out of this version. So, app application handler. Oh, this is actually high. Yes, it's for high. It's in case you can't see it properly. Does this look okay on screen? I haven't got any feedback yet. Do I need to increase? I think I've got a Control Plus here. That's a little tad big. No, I'll stay with that. I can handle that. So there we go. I could go larger and just write downwards, couldn't I? No, I won't. That's not what this is about. Right, so this is the application handler. So this is going to be our event handler here. It's going to be purely abstract, and it's really not going to do anything except filter things through. So that's its job. So everything's going to be public. I could make this a struct, couldn't I? No, I can't, because I'm going to need a copy and a sign if I'm going to do it properly. Everything in here has to be done properly. It's production. This is production code. This is not my test code. Alright, so we'll go with public. We'll do it properly. And we are... Sorry, an interruption. Okay, and what I'm going to put in here is an I application. And that's going to do nothing. So that's okay. Our class isn't. It needs a semicolon. Virtual, yeah. Got to do everything properly now, unfortunately. So that's the application virtual destructor, which does nothing. Okay. So what are we interested in doing with this application handler? Well, it's an application event handler for starters. So I've already done something wrong. Let's call it an event handler. Do it properly. Name it what it is. Right, so this event handler is literally going to do filtering. That's all it's going to do. It's just going to filter stuff through. So you'll see how that works as we go along. We've got a virtual void on key down. It's obvious when you see what I'm typing. It's nothing surprising is going to happen here. So uint 32. Yes, I now have to specify the size of my uints. And it's going to be a key code. With SDL 2, we're going to use key codes. And a bool to say is it a repeat or not. Repeat means as in key held down and just keeps repeating away. So that's that one. That does nothing. Get that out of the way. I'm just wondering if these colours are alright. I can hardly see the virtual. Can you see okay? Or do I need to open a browser and check this? Let me know if the colours are bad. I'm hoping that they're okay. This is just one I selected off the list that it gave. So I just get used to them as I go. I'm not really bothered. Virtual void, and we are going to do on key up. On key up, and no surprise, it's a uint 32 key code with a bool repeat. Is repeat. There we go. That should do nicely. So, on key down, on key up. You might, if you've seen me do this previously, with the way I did it last time, this is going to be a similar idea, but more abstracted, to be quite honest with you. Once all of this is done, we won't be dealing with this back end ever again. Once the back end's written, we won't need to go there again. We'll just be using the front end to program with. That's the idea of this. So we're abstracting away from the operating system to be able to code in our system, which is just an OpenGL thing. Nothing different from what you've seen me do before in OpenGL, so there's no surprises in there, except for maybe the wording of some of the things, because I normally don't do that, but it's production and I can't. I've got to go by what they tell me to do rather than what I'm allowed to do, naming conventions and all the rest of it. So everything has to be done properly. I am limited now. Uint32. So this is on mouse down. This is a mouse button. So Uint32 mouse button. Really? You can have that many mouse buttons? Surely not. Okay. Uint8, which is what I was expecting. Num clicks. So it'll count 0 to 255 clicks. And then it'll give up. So anybody who uses an auto clicker on our game will soon find they have problems. And let's have a look. So that's on mouse down. So I think you can guess what the next one is. It's going to be virtual void on mouse up. Yeah, looks okay. And it's the same. Uint32. Mouse button. Nothing surprising in here at all. It's literally a virtual class. Uint8. So it doesn't do anything. It's a template type of thing. Clicks. And as we did with our last virtual classes, we'll be inheriting from them, of course. So that's our mouse buttons and our keyboard done. Anything else we might need? Yeah. We'll have a virtual void on mouse move. So we can track the movement of the mouse. Left, right, up and down. So that's going to be an int32 because it's in pixels. Across the screen and up and down screen is an integer. And it can go negative. So we have to have an int. So it's mouse pos x, comma, int 32, mouse pos y, comma, I'll come back across again, int 32, I'll call this delta x, in other words the change in the x direction of the mouse, how far it moved, and int 32, we'll just delta y. Delta means change. I think that's fair enough. I think I've talked through that before now. We're okay. If I'm saying anything that you don't understand, please put it in chat or in the comments below. I would prefer to use things like words that people know. Yeah, I'll need a private as well. I'll keep this definitely private to stop people using it. Right, to stop something from happening, you can use this kind of inheritance trick where under the private section, I've already got a macro for this, it's null copy. So what you do is you detail your copy and your assign constructors. Null copy and assign. Yeah, I've got it. And that's just going to be I application event handler. That'll do. And that's doing something. So null copy and assign is inside common. So if I open up common, we should have a definition for it here. Null copy and assign. What it does is operator equals const t other void other and t const t for type other void other. It's just putting the copy constructor and the assign constructor in so that when the compiler gets to this, we will have it defined. The compiler won't put one in for us, and of course it's private, so nobody can use it. Only this class or inherited. I'm not even sure if inherited can use privates. If you inherit public inherit, should I say, that should be locked away, if I remember rightly. I might be wrong. We'll find out. So, we've now got our brand new lovely doubly thing. Let's just build. I want to get rid of those warnings, don't I? Alright, it stopped warning me. Damn. That's not good. 1 second. Not sure I like it doing that. Let's just rebuild from here. No. It's given up on the warnings. Great. Thanks. I should have noted them down. Because I thought it was going to do something stupid like that. Never mind. Oh, it's that one to get rid of it. Thank you. Learning my keyboard controls. So that's that. It compiles, doesn't do anything. Okay. So that's in there now. I hope it's in there. Otherwise I'm going to look a bit of an idiot at the end, aren't I? So that's core. Next, we need to feed the operating system events through the code we've just written here. So where's our operating system events? It's going to be under platform. That's there. SDL we want. SDL, and it's going to be in this SDL application here. So here we go. Alright, so let's add in the header, I am guessing. Yep, so let's go hash include, and it's just going to be core. And that's going to be slash, that big long one there, please. SDL application. Right, process manage. Here we go, process messages, should I say. This is the events. We've got a double delta in there at the moment. So I'll put a comma, hit return, and we're going to add to that. Go back one. There we go. I application handler, event handler, sorry. And I'm going to call that and event handler. So that's where we're going to have that. Just wondering if that's right or not. I think it is. Should be. Alright, let's alter the CPP file. So, process messages. We need to add that line. And that is process messages. Here we go. There we are. That'll do. How are we going to use them? We're going to use them in here. Okay, that's that. So what have we got? We've got poll events from SDL, and here's our events.type. We have cases with the default. Okay. So we can just add this straight in, can't we? Yeah, we can. Alrighty, so we will go with case SDL underscore key down. There we go. It knows about it, and that's a colon. Case SDL key up. I think it's got that one as well, hasn't it? Yeah, it has. That's an event. So case SDL makes this easy. Mouse button down. MOUSE. It's that one there. Mouse button down, please. What is... Oh, are there two types here? I thought it wasn't one word. Mouse button. Got mouse button event. No, it's all one word. It's just mouse button down. Okay, so you'll do. Lovely. So we've got down and up, and we had one more, didn't we? Case SDL underscore mouse motion. Oh gosh. There it is. Motion. Go on. And right, okay. Let's start the top one, I think. So end that. Into we go. Right, we now have an event handler that we can use. So what we're going to do is we're going to send into our iApplication event handler the following. So we're going to use the event handler, and we can now push dot, and it should say on key up. Oh, it won't do because I've spelt it wrong. There we go. Dot. There we go. On key up. Open brackets. You see how it actually the virtual it's like a template, so we can it makes easy to access and makes everything it just abstracts things slightly and makes things easier to use, because what comes up next in these brackets is, well, SDL, which is the event, which is E. Then we want the key. Okay, we've got the key. Now we need the key system. Now I've got the key system, and now I just want the scan code. So there's your scan code. And that is your key code. Comma. And now we want to know is it a repeat or not? So it's event from SDL, this E here, switch E dot type, dot, it should really be called event, SDL event E, never mind, and we want the key, dot, do we have repeat? Yes we do, repeat, and that is not equal to 0. When it's not equal to 0, it means it's repeating, because E key repeat just counts the number of repeats on the key so far. And we put it to a bool, so if it's not equal to 0, then it's true. Key repeat equals true. So is repeat equals true. In other words, if there's any repeats, that's good news. Alrighty. All I'm going to do is copy that. And I've forgotten something. And nobody's shouting it out already. You shall be shouting it. You haven't done break. There we go. On key down. I think is the only alteration we need there. I've gotten the wrong way around because I'm an idiot. That's the up, that's the down. Helps if I read my own writing here. Exactly the same. Yep. Looks okay to me. End and break. This is very blue. So what do we have for this one? Event handler. Whoops. Event handler. What is this one? This is on mouse button down. That's the next one along. And here we just have E dot mouse, motion, button, key, anything? Button, button, okay. Dot, button, great one, well done SDL, good description. And then we're going to have E dot button dot clicks. Yeah, we'll have that one. That'll do. And that's just return break. Simple stuff, but very weird. I mean, how do you know to do this? This bit here, it's in the SDL manual. You look it up online. Simple. I have to say that I didn't remember this off the top of my head. I had to look it up. There we go. Copy. Mouse button up is exactly the same, except it's called mouse button up on mouse up. So we can break on that one and carry on. And now we get to the final one, which is event handler dot on mouse move. That's that one. What do we put in here? Alright, there's 4 things, isn't there? So it's E dot motion. Yeah, motion dot X. Lovely. Yeah, it's in there. Comma. E dot motion dot Y. Comma. Then I'll press return and we'll just go back over. And then it's E dot motion dot, is it rel? Real? Xrel. Xrel, that's it. Relative. The X relative movement and the E dot motion dot yrel. That's the ones. So that's what you want to put in there. So I've got emotion x, emotion y, emotion xrel, and emotion yrel. So those will now send those events through our input event handler. Input application event handler. That's where those are going to go. Ah, lovely. I hope. And Control B. Okay, I've got these things back. Let's find them. So it's 92 and 93. What's wrong with process message? Right, I'll come back to you in a second. Run scale X and run scale Y are not being used on 92 and 93 of main. So let's find main. That's U. And U. There we go, that's that one sorted out. Okay. And try building again. Alright. Why are you still giving us a warning? Oh, that's on 91 as well. Never ignore warnings. That's that one there. Okay, save that out. Control B. Right, let's have a look at this one here. In file included from. Oh right, yes, we haven't included that, have we? Yeah, we've got nothing using it. No, that's fine. What that's telling me there is that our main program has got no clue now what the heck this is about. It has no idea what we're doing. So we'll sort that out when we get to it. Thank you. This is just output, isn't it? Yeah, that's okay. Alrighty. Control space thingy, whatever that is. I could just put it in and see if it worked. It's here, isn't it? Holy mackerel. How am I supposed to see the red squiggly? Ah, it's there. Too few arguments in function call. Ah. Process messages, of course. Because now we need the iApplication event handler, and we haven't made one. Good. So it knows that we are working on it. Good. So that's working nicely. I'm happy about that. Alright, let's see if we can make an example, shall we? So that's all done. I think we're going to do it in main, aren't we? Yeah. I just closed it for no good reason. Okay. Alright, let's start at the top. Alright. So it's hash include, and we're going to have to put in core slash that one, because we haven't got it. So that should do there. Alrighty. Run test window app. I wasn't guaranteeing that that would be there. Yeah, I know what I'm doing. I think I've got it now. I think. Yeah, it's coming off this event handler. So, right. I'm not going to make a file for this. I'm just going to do it here. I think that's the easiest way of doing this. So, what we're going to do, we'll have a class. We'll just use this include. Temp event handler. You know, it's going to be destroyed, don't worry. This is going to get deleted. It's so that we can do that. That is correct. Wow, this is ace. That's a class. Public. Bool. It's going to be a massive class, this. It's going to be dead complicated. It's going to have a key down. That's going to equal, let's say, false, because that's a good starting point. Constructor, temp, event handler, constructor. I don't really want it to do anything. I'm not really bothered about that. Right, let's give it. This is how we program it, how we use it. We take our application event handler, we inherit from it to whatever kind of event handler we want to use. In this case, it's going to be a keyboard one, and later on mouse, I suppose, as well. But I'll do keyboard first. In fact, I'm only going to do probably horizontal. We'll do the A and D keys first and see how we go with that. And this is the front end. So we've done the back in the SDL. It gets transferred through the iApplication event handler to this front end, which is a temporary one because I'm just doing it as an example. And this is the kind of thing it's going to be able to do. So I'm just going to put in a virtual void so I don't mess anything up. I think I am going to mess this up actually. Key. I can't put virtual in here, can I? It should template. Key. Down. And what we're going to do here is have a uint32 key code. I'm just setting it up exactly as it was before. In fact, the best way to do this is not this at all. So that's where I want it to go. Under platform, no, we've done that. On core. So I just want these first two here. So that's all I'm going to implement is these first two here. So let's borrow those, copy. This is when copy and paste does come in handy for me because I can never remember everything. Have I got common? Well, it should be in there anyway, doesn't matter. Okay. Right, so what's this one going to do? This one is going to do key down equals true. How's about that? That's a lot of functionality, that is. And the other one on key up, what we're going to do is key up, no, key down, isn't it? Sorry, we're only using one variable. Key down, gosh, I could get that wrong. Equals false. There we go, that's happy. So we now have a temporary event handler that will log a key to true or false. Or any key, absolutely any key on the keyboard, if it's pressed, will switch the state of our temporary event handler between true and false. So you press any key down, it'll go true. Any key, just remove your hand off the keyboard and it'll go false again. Okay, so you can mash the keyboard, you can do what you want. Right, so what we're going to do with that down here, where's the bloody main? This is a rendering of the devices. 1 second. We've already altered this, so we may as well continue in here. Render device. Edit sync, end scene creation. Yeah. And that goes into our main while loop. Right, so this is the main. I'm going to have to take that out, it's messing me up. This is totally messing me up. No. It's marked in red anyway, so I know what I'm doing. Alright, so let's start here. Let's start here by making temp event handler. We'll just call that event handler for now, because we've only got the one. So I'm going to put that out by itself, so I know that I've done it. So our problem down here is that processing messages is now incorrect. But we can do something about that now because we've got an event handler. So we can put in comma event handler. Alright, and it'll accept that. That's correct. Right, a couple of lines down from there we should have set rotation, here it is, and a for loop. So I'm going to mess around with this for loop. So this is doing the rotation, isn't it? Yeah, it is. All we're going to do is use that event handler to switch this on and off. Oh, sure, that's supposed to be an address. We'll see. So it's this for loop here that I'm interested in. So what I'm going to do is, if, we'll put a condition in, event handler dot key down. Alright. I'm going Just do that. Tab, tab, tab. Oh, they've styled it, haven't they? I'm not allowed to use that style. I've got to use that one. I hate it. Okay, so that should do it. What should it do, you're probably asking? Well, every time I hit the key down, that's going to become true. And that piece of code is going to run. So let's build. See if we can build first of all. It looks as though it's done it. Okay. I wish you wouldn't do that. It comes back out here. It should come back out in the window. Okay. What's this rubbish? We're in the build directory, aren't we? Yep. Right, so it's static. There you go. Hit a key. It starts moving. Take key off. It's static. Hit the space bar. It's moving. Hit any key and it moves. Otherwise, it doesn't. That shows that that true and that false is going from the keyboard through SDL. Oh. What was that? What was that? Oh, it's just glitched on me. Great. Great. Great, great. Microsoft, can you please do things at work? Alright, we'll try it again. See if we can spot what went wrong there. I got to about a screen full and then just went off. But my frame rate, oh, it's 60. So we're holding on frame rate. Oh, it moves. Does it keep moving away? I like this. So now you can see how we have taken SDL completely out of the equation and sent it through here. The escape key does the same. Escape just moves the head around. Oh, there it went again. I know what it is now. That's okay. Thank God for that. What's happening there is I haven't told it which graphics to use. I've got to sort this graphics out. And that's in CMake, isn't it? Anyway, I'll do that after. Control splodge. Let's go back into here. So that's how it's used. You can use it as an literally an event handler. In this case, for true and false. All right. So we can make a better event handler than that, I think. But that gives you the idea how you can take something that's more complicated and make it so much simpler. The whole idea of that is called abstracting. Come over here, you Mr. Microphone. Alright, so what I'm just introducing you to is the idea of abstracting. So what it is an abstract class. Okay, and that's the event handler, complete abstract class. As you saw, it does nothing, but when you include it in the events and ask the events to report to its functions, then that enables it. It enables it to do something. It enables it to report those events through the abstract class into something that inherits it. So that really should be inherited. Actually, I'll do this bit again now. So I think we can redo this. Can I bin this or not? Edit. Clear canvas. There we go. Thank God for that. So what we have at the top is our operating system. Our operating system. Doesn't matter which operating system you're on, which is going through to SDL2. Okay. So I use the event system from SDL2 to take those operating system events and put those through or into an abstract class. Which then in turn is inherited. So this is just the event handler, I'm going to call it this time. So event handler. So this is the bit that we're interested in. So it's public, inherit, abstract class. Here we go. So what's happening in reality is this event system is leaving information in our app. It is sending through the abstract class. It doesn't actually stop there. Any information does not stop here. It goes straight through to whatever it's inherited to. This is like a stepping stone, a bridge. So this acts like a data bridge. I think that's the best way of putting it. So your abstract class is acting like a data bridge. So the events are coming through it, or over it, or across it, or whatever you want to call it. It's coming through. The data goes like the actual event data goes through here, through here, through here, and then across, following the inheritance, and finds its way into here. And that's how it works. And all we're interested in is this. That's the bit that we want as the programmer. And we can make that do anything we want with whatever those events are that are coming in. In this case, we've restricted those events to keyboard events and mouse events. So this event handler would be written for the input of keyboard and mouse. There you go. And I think that really engulfs the system into everything, absolutely everything. The whole system works in that. So we'll just review it on, where's my mouse pointing on here is. We'll review it in code. In code, you write in your core, in the core of whatever your application is, you write an application event handler, which does absolutely nothing and is void. All right? So it does nothing. Everything is void. And you also put the copy constructor and assign constructor in private, so this can't be copied, or shouldn't be copied, or assigned to anything else by accident. it'll just stop it from happening. That makes it a safe class, a safe virtual class. This is a virtual class. It does nothing. This is just going to make sure the data flows through the correct channels. In this case, on key down, on key up, mouse down, mouse up, mouse move. And we write those in to whatever we use. In this case, we're using SDL2. So we write that in to our event cycle within SDL2, which in this case is platforms, SDL, SDL application has it in. So obviously you include it, you take your events, which is process messages in this case, alright. Don't put red dots there, please. And in the messages, where we do all of the event handling for SDL, we just put in all the case types for key down, key up, mouse button up, down and up, mouse motion, and we send them through the event handler here. And that channels that information, that data, through to whoever inherits the application event handler, who we quickly wrote in main, of all places, at the top. We haven't made a class yet properly. We've just made a temporary class at the top of main for the data to come through. And we're just checking on key down, we'll just say true. And if on key up, we'll just say it's false. That's all. We're not even looking at the key code. We're not even looking at the data it's passing through. All we're just doing is, well, a key's been pressed. Let's make true. Let's make our value true. And if a key isn't pressed, we'll just make it false. We've then used that back down here again. There we go. So we make, from the class, we just make an event handler. The event handler gets passed through our messenger, which is inside. There we go. 159 here it is. So our event handler gets passed through the process messages, and ultimately we can now ask if the event handler has its key down, true or false. So whatever state that is down. I think I made it public. Yeah, I made it public, so we can access key down directly. Otherwise it would be get key down if you make that private. Some people would, I couldn't be bothered. That's it. I think that works for this kind of event handler. It also means, when you think about it, you could do quite a lot of different event handlers. For every single event that the operating system sends out, I'll just go back to SDL2 a second. Just get rid of you a second. Nothing's on chat, okay. That means I probably confused everybody and they've all gone home. Oh well. Hope I haven't. I'm trying to make this as easy as possible. We have a switch of E-type, and that's an event. So we're polling the events using SDL here. What events can we have? Easiest way to find out is just say E dot type dot, no, it's not going to give it, is it? E dot. We have gestures, motions, padding, quit. We haven't got a quit. Ooh, we haven't got an escape key yet. Sensors, system, Windows Manager, text, touch finger, different types of events, user events, wheel events, that's the wheel on your mouse, more window events, display, drop, common, C button, C device. Oh, ball button thingy devices. Oh god, what do they? Joystick type things. Oh, I didn't know it had those in there. Interesting. There's each individual key can be measured. But you wouldn't do that here. You would do that at the other end. So as you can see, SDL has the ability to do all of that. But all we're asking SDL to do for us is tell us whether the key's up or down. And then pass on the scan code. So there we go. We haven't checked for an SDL quit. That just does the top right hand corner window. So if I were to run it, so run, it's not going to do it. It's not going to let me do it now. I don't think so. I think I've crashed the virtual graphics card. No, it's not. It's top right hand corner. I need to reset that now. Damn it. Oh well. Exit from that bit then. Thank you. That covers an introduction to our input on how to separate everything down and everything else really. It's a nice little simple idea. So that's the only things that we've done. So I'm going to call this part 1. So this is day 1, isn't it? What can we title this as? Yeah, doesn't matter about that part. What have I done? That's what matters. Creates an input backend using SDL, using the SDL platform. Actually, it's SDL2, isn't it? Via 3 characters over 15 current line. Didn't know there was a limit. We did that via a core abstract class. Application event handler .hpp. Comma, which can be inherited to make an event handler of some type for input. That's what the thing is, I suppose. Source control git. Okay, click. Done. Magic. So I've sorted all that lot out. Why can't I push here? Sync. It's not coming up down here. Alright, sync and push. Ah, right, it's got no room. Thanks. It has. No, it hasn't. So just go back to the master, I think. I'll sort that out. So that's basically what I wanted to cover. We do have time for questions, if anybody wants to ask any questions. Next time, I'm probably going to finish that off by putting some keyboard controls in, I suppose. And that will then give us a way to go on to the next part. So we need to do the front end. Here we go, yeah, alright. Let's just resize this and do this. So that's what we've got so far. Alright. So what we're going to do on the next part is go on to the front end. And create proper classes and stuff like that. And I want to lead this towards ECS. So I'll put an arrow down here to ECS. Alright, so there we go. Now if ECS scares you, it shouldn't do. It's an entity component system. It's very, very, very straightforward in terms of how to think about it. It gets a little bit complicated for the component side when we want to set it up in C++ because we don't know what components we're going to be using for each entity, which means the component system has to be dynamic. In other words, it cannot be known prior to runtime. You will not know what the components, which entity's got what components until you run the program, if you see what I mean. You can't preset your entities fixed, as it were, because components can be injected and taken out. They can also possibly even be modified during the lifetime of the program or created on the fly. Components themselves have to be dynamic, and that's going to cause, well, me some problems anyway. The system side of it, the S, is the easy part, really, I think, because that's going to just be like the front end that you've just seen. That's just going to do something. That's going to be the functionality part. It's going to take a component and do something on the data within a component, or do something with the data within a component. The entity is going to be explained in a surprising way because it's like a VAO in OpenGL. It's just a list of components. That's what an entity is. So the entity is our bridge. So we are going to have components, then we're going to have a bridge, an entity, and then we're going to have a system at the end of it that takes action upon the component of the entity. Does it look similar? Yes, it does. That is why I chose this way to do the keyboard, because funnily enough it prepares you for the ECS system. If you can get your head around what we've just done for a keyboard, then ECS, even though it looks complicated when you type it out, it is just as straightforward as this. Event abstract handle, because that's all that is, event abstract handle. How you explain it is difficult, so I use acts like a bridge to explain it. It's easier, but it doesn't work that way at all. What you do is you create your event handler, you then pass it through to the event system that picks up the data and modifies, via the abstract, okay. And the abstract class just acts as a template for the two, I know. But it's better to think of it as event data is being passed through, and this is acting like a bridge, because it makes the flow of your data simpler to work with. I think we want to think of our data, which is going to be in a component this time. The event data is going to be the component coming through an entity, or coming along an entity, or being stored underneath an entity and passed into a system. Okay, I think I've gone far enough with that explanation, and I think there's a lot to digest for one day. I mean, this is the first day of this, so I'm going to be covering it over a few days, and it should be okay, I think. I'm quite happy so far with the VM, even though it doesn't know what OpenGL is yet, but I'm still working on it. I'm still working on this virtual machine. I'll be using this, by the way, for tomorrow as well, this virtual machine. I haven't got it set up and running. It doesn't have JavaScript on it yet, but tomorrow we'll fix that. Okay. And I've got to go back and fix all this. Alrighty, I'll leave it on screen. Actually, I can't. I'm going to have to reset it, aren't I? Oh well. Never mind. And in the meantime, I would like to thank you for joining me for today's session. Any questions anywhere in chat? No? That's good. Excellent. So I'll mark this one down as the keyboard episode. Episode 1, Introduction to Keyboards. How about that? That should be fun. And then if people want any subjects that they want to do, I will do them. I now have a system that can cover most things, I think. Yeah, it can. It'll just redo itself now. And I'll go and sort some more of this system out. In the meantime, I'd like you all to take care. I'd like you to carry on programming, carry on exploring, carry on learning. Learn all the time. And above all, make sure that whilst you're doing it, you're having fun.